Use augmented matrices and Gaussian elimination to solve the system x minus 3y plus 2z equals 12, 2x minus 5y plus 5z equals 14, and x minus 2y plus 3z equals 20. We'll start by writing the augmented matrix for this system of equations. It has entries 1, negative 3, 2, 12, 2, negative 5, 5, 14, 1, negative 2, 3, and 20. Remember that our main goal is to turn these three entries into zeros. Because we're not changing anything with the first row, we're going to leave those entries as they are, and then we're going to choose row operations to help us get zeros in the first column for the other two rows. To change this 2 into a 0, what we can do is we can take row B and subtract twice row A from that. If we do that, B minus 2A, then that gives us 2 minus 2, which is 0. And then negative 5 minus negative 6. And when we're subtracting a negative, we're adding, so that becomes negative 5 plus 6, which is 1. We've got 5 minus 4, 2 times 2. 5 minus 4 is 1. And then we've got 14 minus 24, because 2 times 12 is 24. 14 minus 24 is negative 10. So we've got one of those zeros. Now to get the next 0, what we can do is we can take row C minus row A, because 1 minus 1 gives us 0. So we've got C minus A. So 1 minus 1 is 0. Negative 2 minus negative 3 is the same as negative 2 plus 3, which is 1. 3 minus 2 is 1. And then 20 minus 12 is 8. So this is our third row now. At this point, we still have one more entry that we want to turn into a 0. So because we're not going to change the first two rows anymore, we can just copy those out. And then we have to determine a row operation that will give us a 0 here. And the easiest thing that we can do is take row C minus row B, because 1 minus 1 gives us 0. So we've got C minus B. So here 0 minus 0 is 0, and then 1 minus 1 is 0, and then 8 minus negative 10 is the same as 8 plus 10, which is 18. And at this point, you may have noticed something interesting here. We've got 0, 0, 0, 18. If we rewrite this as an equation, the left-hand side is 0x plus 0y plus 0z, which is just 0. And so we end up with 0 equals 18. We know that this is a false equation. And so what that means is that the original system of equations has no solution. If we ever end up with a row that is full of zeros, and then the very last number is not 0, that means that there's going to be no solution, because that is a false equation. If, on the other hand, we get a row that's entirely zeros, that is a true equation, and so we throw it out, and we look at the remaining rows, the remaining equations, and we should have infinitely many solutions at that point, which we can parameterize as we did in one of the examples in the last lesson. But for now, this problem has no solution.